engineering as well as management of engineering companies. He is the CEO of RAFA Solutions LLC and Data Logger LLC. Being in these positions, Rafayel was able to build teams to deliver custom systems to customers in 4 continents. Their academic products, they've been one of the major directions that the company has taken, and recently it's gained a lot of market interest. All of these products, Rafayel himself has worked on the business development. So let's welcome Rafayel, and he's going to speak about the industrial Internet of Things in education.
Hello everyone, welcome to NI Forum, Academic Forum. Today I will be talking about one of the teaching labs that we have created and which is already released and available for sales, which teaches about the IoT. So let's start with a bit of history and basically talking about what is IoT. I would like to see your hands. Who is here who knows about what is IoT and who has heard about the word of IoT? I see. So there are many hands, and basically, as it's kind of a trendy word. It's something that is on the air, but many of us does not fully understand what does that mean. What is Internet of Things, and how is it going to change our life, or anyhow is it going to change anything? So basically, there is some kind of research that we have done, and we have actually find out the research of McKinsey and like different offices. As you can see on the slide, it's showing up that there are 14 trillion economic value by 2030 that's going to impact the IoT. As Travis was talking half an hour back, he mentioned about the autonomous vehicles and about many different other applications where the same IoT is going to change our life. So that's on the side of the industry and on the overall world value for the IoT. You may see also other numbers on the slide. I would like also to mention about the key barriers. Basically, what's making us, challenging us to go and to have it not by 2030, but today or next year, let's say. So of course, it's a technology, and it's about creating and having this innovation done. So we will need to have resources, mostly human resources. And as you can see, as per the research shown, it's 50% of the barriers are the human resources. And you can see like 47% of organizations are lacking the skills for making most of the IoT development. So all these kind of numbers helps us to understand that, okay, there is some need for the IoT in education. So the problem that we have recognized is about the issue that basically the universities, the traditional universities, engineering universities all over the world, and especially in Western culture and Western countries, they have either electrical engineering department or computer science. So they teach for hardware engineering or software engineering. So it comes out that in the our real life, when you enter to the industry, to the market, it's not that divided. So when you want to create something, some product, nowadays almost all the products are starting to have some software on that and some connectivity. So they need to connect to your mobile phone, to some cloud, to broadcast the data for the monitoring or for the control. So there is a gap between the programmers and the hardware engineers. So with this product, we are going to reduce that gap between the software and hardware. Another research we did, this was done 1.5 years ago. That's when we started our research and development for the IoT. So you can see, we tried to find out what's there in the market for the courseware, for the content to deliver in the universities as well as in the industrial institutions. So what come out, actually it's very less. As per the research we did, like 1.5 years ago, there were very few institutions who actually have something officially related somehow to IoT. So you can see there are, at the moment we have shortlisted 3 universities and then 3 companies which leverage some IoT courses. So this brings us to the idea that this is really something important that we should take care of. We should start by contributing our time and resources to develop. Okay, so now why IIoThink? You may notice the name, but you can see this think. Think means like basically the IoT. It's an Internet of Things, and industrial Internet of Things is the well-known term. So we try to combine that with thinking. So this is our trade name for the product, and the IIoThink is something that is going to cover the subject, starting from the introduction to the engineering, like about the sensors, data acquisition. I will talk more in details on the upcoming slides about the particular experiments that are covered. But you may notice it's going to cover all the introductory course from the data acquisition up to the broadcasting the data to the cloud. And we collaborate with the PTC TeamWorks and IBM Watson for the cloud connectivity. And we currently collaborate with National Instruments for the hardware platform. And at the moment we use MyRio, but we have even more plans I will show further. What's the impact? It's very much important to understand whatever product you're creating, is it going to have any impact? And if yes, is it going to have a positive impact or negative impact, or how the education is going to change as per the development? So we did some kind of analysis for short-term and long-term values. And as you can see, it's going to reduce the skill gap between the software and hardware engineers. It's going to make the time, like when a student graduates the university, and after that he wants to apply for a job or he wants to start his own business, let's say. So that is most of the time, even in the United States, where it's considered that the project-based learning is something that is leveraged quite well, or in Estonia, for example, or in Finland. Those are the countries where project-based learning is somehow more leveraged. But still, there is almost no case where somebody graduates and he has enough knowledge and skills to start development, to start building some product, or doing the engineering. So with the help of this one-semester course, which is basically an introductory course, you are not becoming an engineer because of the IoT course. You are just learning the language. You are understanding like being on the same page with your peers who graduated the other discipline. So that's the major value. So basically, it's reducing the time to enter the industry. That's on the long term. So now let's talk about the product. So what is it about? So we have the software, the hardware, the curriculum, and the cloud. So the cloud connectivity. On this slide, you can see at the moment what is supported and what's there. So for the hardware, that's the NI MyRio. We have it also includes the special kit created for this lab. It's called IoT Teaching Kit, which includes the sensors, actuators, and various components to be used in the experiments. And then the most valuable from all this everything is the courseware. And we'll be talking about the courseware in a bit more detail on the following slides. Okay, now about the software. So what does it include? The version that is now under development and will be released in next 1 or 2 months, it's going to have 10 experiments. The current version has got 5 experiments. So it's going to include 6 basic labs, then 3 project-based labs, and 1 advanced lab. So overall, we'll have 10 experiments. And it's going to cover duration of 3 months of teaching. So what the courseware is comprised from? I would like to mention about the first section where we talk about basically we talk about the applications. We mention where this IoT is going to be used. And that can bring for the students some startup ideas. Because tomorrow, they have learned about the electrical engineering. They know how to build a PCB. But for them, for those engineers, at the end when they start, let's say they enter an automotive market, or they enter the market in oil and gas. So they need to apply the knowledge of this building the PCB, combining with the software programming and joining with the cloud and so on. So the curriculum is giving them the ideas, what they can do with this background knowledge. And of course it covers all the basic parts of the engineering, like the control systems concepts, data transmission protocols, statistical analysis, because we have the big data. So without knowing what's there, how you should do the analysis on the data, it's very challenging nowadays to filter from these millions and billions of data. Okay, some words about the procedure, about basically what is included and how students should conduct the experiments. So you can see here, these are the parts of the software that helps you to conduct the experiments. It's the task description, hardware configuration, how to run the system, how to do the wiring. So these are all the parts of the software, and it includes also the quiz. So the quiz at the end is checking up your knowledge, and it's kind of either proving that you understood or vice versa. So because this is being said at the end, it's reported, and your professor can see and understand whatever you have learned, is that done correctly or not. Okay, a bit more detailed about the 6 labs, about the fundamental experiments, and then I will talk also about the advanced and the project-based labs. So you can see it covers the introduction to sensors and actuators. It is covering the introduction to data acquisition, the control systems, conversion the sensors data to the physical quantity. By the way, at the end of the presentation, we will have a small video demo, and I would like to show you one of the, I think the most easy experiment, which is covering the conversion from sensors data to the physical quantity. Because you know, like you have a voltage, then you need to at the end to measure, let's say, distance or a temperature. So then we have the statistical analysis lab, and then the transmission and reception of the data. So these are, you can see it's not related to the particular application. It's very general. And now talking about the project-based labs. We have decided to include some interesting, more long and more challenging labs, which are about the temperature monitoring, warehouse automation, and remote irrigation. So these 3 labs are included into the system, and student is being able to create actually the real irrigation system using the components in the kit, and with the help of MyRio as a controller. And we have a plan to include also renewable energy management and renewable energy related labs, which will also have a real plan included into the system. Okay, and I want to just show you how it looks like. These are the project-based labs. You can see the temperature monitoring. On the right side, you can see the list of all the components that are included for this particular case. And on the left side, you can see the circuitry, the circuit diagram, what they need to compose, what they need to make on the breadboard to be able to run the system. Similar to that, this one is for the warehouse management, and then this one is for the irrigation system. So you can see student is being able to use various, in different project-based labs, they use different sensors. They use different components, either digital or analog, or like they actually do something with like themselves, and they learn by doing that, so that it's not in the manual written and very much guided training. This is also something that Travis mentioned on the keynote, on the first presentation, talking about the project-based learning. As you can see, it's much more intuitive, I would say, effective learning way, because this way student is being able later on easily adapt to the industrial environment and to the actual knowledge that he needs for the industry. This one is the advanced lab. This is the only lab for which the student will require to know LabVIEW and will require to have LabVIEW environment on the computer. So here, they will need to do some kind of programming. So there will be this many, like 9 exercises including, that's just one, it's included into the advanced lab. So within this each experiment, they will be able to do the programming and to see the results using the lab environment. And of course, if this one has got a very good descriptions in the manual, and it's helping you to learn how to do the programming, even though you may be an electrical engineer. So it's not advanced. It's advanced compared to the previous labs, but still it's not about programming. You don't need to learn from zero. Going forward, these are the sections of the courseware, how it's organized and what's included into the content, and how much detailed it is. Okay, so now talking about the future. So what's our roadmap and what are we thinking to have next? So as you can see, each section of this IoT, the software will remain the same environment, although the technology will be different depending on the platform that we use. On the side of the hardware, now we have the support for NI MyRio, but we are very soon, hopefully by the next NI week, we will have the release for NI LDIS 3, which is a similar platform, but it has got the not the breadboard, but actually you can make your own circuitry on the system itself. So it's much, much more convenient compared to the MyRio. It has got the FPGA, it has got all the functionality that MyRio has, and at the same time, it has new technologies to connect to the cloud and easily to do the programming remotely through the web. So that's on the roadmap. Similar to hardware side, we are also planning to support more cloud systems. We are now under discussion with the TeamViewer to have the TeamViewer cloud included. We have ThinkWorks, we have the IBM Watson, we have also plans to include Microsoft Azure and AWS from Amazon. And yeah, the courseware is something that will remain always. Basically, the content will be delivered through various diversified technologies. About the sales model and business model. So basically, it can be downloaded online over our website, and it can be contacted to the National Instruments direct sales for depending on the region. And of course, we have resellers for particular regions where the sales is done for the distribution channel or the indirect sales. I would like to announce that today we have signed an agreement with Egyptian company, it's Smart Integrators, to become our exclusive partner in Egypt and to resell not only this product but also other products that we have, and they are official partner of National Instruments in Egypt. So that's kind of a starting point. Similar to that, we are now signing agreements with various distributors in different countries where National Instruments does not have a direct sales present. So anyone here, I know there are distributors as well. If you are interested, we'll be happy to show and to have some discussions over the product. Going forward, some information on the pricing, and as you can see, it includes the different packages: 3-seat license, 10-seat licenses, 20-seat licenses, like classroom license. And you can see that it can be sold either with the hardware or without hardware, depending on the universities. As you may know, there are many universities which already have National Instruments MyRio available, so no need to buy one more time, so they can directly go and buy the content and start using it. Okay, so now about the demo. So this is the lab. It's opening. Let's open the lab. You can see this is the 5-lab version. So let's start with the manual, with the content. So it's showing the courseware. It's delivered like this, the regular Windows environment. You can see each lab having its own package, and for each lab you can have all the connectivity and all the information. Now connecting to the hardware, and just it shows that the connection is on, and now we can start the conversion from from sensors to physical data. So this is the wiring instructions. You can see the data showing what should be done. We are currently going to use the IR sensor, the infrared sensor, to do some measurement on the distance. So we do the hardware configuration. Now let's put the, so there are several ways to do the conversion with polynomial and with linear conversion. So we need to put the equation for linear, in the case of linear, and then if we want to have the polynomial, then we'll need to mention several points, and then the software is automatically calculating the corresponding polynomial equation for the particular conversion. So this is, I think it's quite simple. You do the measurement, you measure some millivolts or some voltage, and then we need to assign each voltage corresponding value on the distance. Like when we do the measurement, we see, let's say 10 centimeters corresponds to this voltage. Then we give it the value, and then we can see how it's scaling and accordingly showing the correct information in centimeters. Okay, so now I want to show here how the broadcasting is happening. Basically, there are several ways to broadcast. In the previous slide, you saw how the broadcast goes for the IBM Watson. And here we are configuring, see, okay? So we have the random ID, which now the browser will be open. And on the browser, we need to give the device ID, and we press here the send button, and it starts sending the data. So now you can see in the real time, how the same information is shown on the desktop application as well as in the browser using the IBM Watson cloud service. Similar to this, now let's try, okay, it's showing with the other equation. So when we change the scaling to the linear instead of polynomial, so we'll see again the same information is being transferred. So now let's try with the ThinkWorks. That's another cloud platform from the company called PTC. It's a US organization, very much famous for the industrial automation, for the industrial IoT cloud platform. So it's a bit more challenging here. You will need to do some preparation in advance, and you will need to have the IP address for the server of this PTC. And if you include the correct IP address and you put the key ID, and then there are tags and the thing name. So we need to give the thing name, we need to give the properties. So initially we did some kind of preparation, that's why it's not taking a long time, but otherwise just doing this ThinkWorks setup, it's something that will take for the student around like 40 minutes to learn and to be able to do all the setup on the ThinkWorks. Okay, now let's put the property name, and we will need to put on for sending the information. So still it will not be broadcasting before we press the send button. Here we don't have any waveform, just the data is shown on the digital indicator. So now you can see the exact values are being transferred to the cloud, and it's showing on the browser. So basically, it's very simple. This video just demonstrates how easy it can be to study about the broadcasting to the cloud and overall doing the data acquisition and conversion. And now I would like to talk about a bit and show you the quiz part and the final report. So going forward, so this is the quiz for this particular lab. So this student did wrong answers, and now he or she is putting name and all the information, and then the report is being generated. So afterwards, the professor will see if student did anything correct or wrong. So this person may done everything correct on the lab side, but then he didn't answer questions correctly on the quiz. So all that information will be shown in the report. At the moment, with this new version, the report is generated with the PDF and with such a way that the student cannot modify afterwards, and it's directly sent to the email of professor, so that there is no way like kind of cheat or later on to change. But in this demo, you can see the Word file. It's showing all the information: who is the student, which university, which faculty, and what she or he has done. Like all the information of the lab, as well as the answers for the quiz. Okay, we are done with the demo. Thank you very much. I will be here available for another half an hour, and I'll be happy to share more information. And if you have any questions or anything, I'll be happy to answer. And now we have, I think, another 5 to 10 minutes for questions, or is that
Yeah, exactly. So if anyone has any questions, this is your chance.
We'll give you the mic.
I knew you were going to be first.
Thank you. It was a good speech. From what I know, you are so knowledgeable. You will give. I want to ask you about a problem I faced with my work. That when I want to sample signals, multi-signals, let's say maybe 12 signals, is it possible to have the sampling at the same time, exactly the same time? I mean, having buffer of whole system inside the circuits, maybe the DAC or other.
Okay. I assume it's not related much to this IoT lab, but I'll try to answer. It depends on what hardware you are using. Are you using some national instruments data acquisition boards, or it's based on the FPGA?
No, DAC.
DAC. So depending on the actual hardware, you should be either you will be able to do simultaneous data acquisition or no. So I mean, if it's something like cheap USB DAC, you may not be able to have a very high accuracy between the channels and have a simultaneous data acquisition. For example, with the Mario, and if you do the programming on the low-level FPGA, then you should be able. We can talk it offsite. If anyone has questions related to this lab, I will be happy to answer. Otherwise, I think it's better if we talk
Thanks
about
a
this
lot.
later. Any other questions? Anything that would you like? I think somebody there on the back, please.
Yes.
Thank you very much for having me.
No worries. The exercise of the day.
Thank you for the presentation. I wanted to ask, how is this different from an instrumentation lab? Because you called it the Internet of Things lab. So how is this different from a normal instrumentation course? Thank you.
Yeah, very good question, and that's what actually when we started to do this, we asked these kind of questions to ourselves, and of course, when making the content, it took us more than 6 to 8 months to create the content. So the purpose of this lab is not to teach about the instrumentation. It's not teaching about the data acquisition, sampling rate, although the manual includes those basic knowledge, it transfers this basic knowledge. But the purpose here is an introductory course for the student. Let's say somebody is studying in the university for computer science and he's going to become a programmer. So he don't need to know all the details of instrumentation. He needs to know the basic terminology to be able to communicate with the peer who is the electrical engineer. So this is a very introductory course which covers about all the topics that may be covered in the instrumentation over several years, even not within one semester. So that's the major difference. We're not teaching here about the engineering, and neither we are teaching about the programming. So it's an introduction to be on the same page for the students so that they understand when they graduate and they go to the industry, they do some product development. So when somebody tells them, I have connected the thermocouple into our system and I'm doing this measurement, and this data should be transferred with MQTT protocol. So the engineer don't know what's MQTT. The programmer don't know what is the thermocouple. So after this course, he will know what's thermocouple, and this other guy will know what's the MQTT. So it's connecting the dots within this current traditional education that people are basically learning very much specialized.
Where do you suggest this goes into computer science department, into engineering department?
Both. Actually, we already have selling I will tell a bit about the customers. So we have already 5-6 universities from United States, like Texas A&M, Detroit University, Miami Dade College. So we have several universities that already purchase. So some of them they purchase for the they have cybernetics department. They have the electrical engineering. They also use that there. And some of the universities they don't include into the regular curriculum. Like it's not included as a everyday lessons, but instead they have this one semester as an additional course. So it's given in several faculties. I try to answer, but it's more generic, so it can be there in different disciplines.
Thank you.
You're welcome. Anyone else?
Of course.
Let me know when time is up.
Hi, thank you for the presentation. I wanted to ask if the hardware that will be included with the Mario, do you need anything else connected to the internet? Because how are you going to broadcast to the internet with the Mario? It doesn't have any direct connectivity.
So Mario network and this IoT key and our software and courseware is enough to conduct all the lab. So basically, you will need to have internet, of course, in the lab, in your classroom. And if it's in the same network, so you just connect to the network, and then you can do everything as just, you need to connect either through Wi-Fi or through regular Ethernet, doesn't matter. You're welcome. Anybody else? Okay, thank you very much, and enjoy the day.